mean, doesn't have to have secondary school.
I'm always very good.
He was better than people getting critical.
Okay. All right. Hey, here's what we're doing. In your homework today, you have 5 problems. Now, why I'm only assigning 5, these do take a while. Some of them are a lot easier than others, depending on what problem I pick for you. What we're going to be doing is drawing kind of just a rough scale picture. We're going to be finding first derivative, drawing that picture, doing a second derivative, drawing that picture. You do not need graph paper for these. You do not need graph paper. You are just drawing a very generic drawing on paper. Okay, does that make sense?
Yes.
So I'm going to walk you through this problem. It uses all the parts we talked about yesterday, and it's going to have some new stuff. So, all right, here we go. So let me put all these tests and guides that we have. So.
I went to my skin and I had to get water.
I like the water.
This?
You can squeeze the water into it.
I don't like
I'm waiting you guys out. I'm not going to go through this problem. I'm not going to go through anything until we remain quiet here.
Oh. And this is an example problem.
We're going to do 2 problems today. That's it. The sooner I get through them, the easier it is. I'm going to leave this little chart up here. These are the types of problems I'm going to be handing you, or just polynomials like this, nothing like crazy, no fractions, nothing like that, just very simple. I could have handed a fraction, no, I didn't want to. It was hard enough doing some of these, let alone doing the ones where you have breaks and graphs and stuff. We have y-intercepts. We have symmetry. And turning points. And the turning points is really part of the first derivative stuff. And I said turning points, not inflection points. There's kind of a difference between that. That's kind of the one thing I want to talk about today. Now, I picked just some basic ones. The problems you have today, quite a few of them are really simple. They are really straightforward. You may not even have a second derivative for one of them, just because when you get there it's just 0. Like it's just not even impossible to find that second derivative. So when we go through this, again, I want rough sketches. So I want the original picture, next to it just draw a rough sketch what the first derivative will look like. And I'm going to show you the way that I do it. This is the shortcut way, not like the extreme shortcut that you guys were really questioning. Just the way I showed you yesterday. It seemed like a lot of people had kind of a handle what I did yesterday on it. All right, first we have to factor this thing apart to get kind of a rough scale. I know that this graph, by default, is going opposite directions because the odd power tells me the tails go opposites. Factoring this thing apart, we're going to pull out x squared. In the back, we're going to pull out a -2. So it's x equals 6. And as you can tell, like it is factorable. So we can actually find the x-intercepts. If we couldn't, we'd have to do the rational root theorem or a table and try to figure out where they are. What we have here is x squared minus 2. And this will explain why I picked this problem today as opposed to one I did yesterday. One of these x-intercepts is a nice clean number. What is my x-intercept? -6. Okay. All right. -6. The other 2 are not pretty numbers. They're decimals. I know they are because this thing is actually a difference. It's a difference of squares, even though we don't have a perfect square in there. But you can still break it up using the difference of squares.
What is the decimal?
So it is, it's the square root of 2, it's 1.41. So when you break this up, it'll be plus minus x and x. Then to break up a 2, even though it's not a perfect square, it's not like, if it was 4, it'd be 2 and 2, right? If it was 9, it'd be 3 and 3.
We just change the problem.
We just take the square root of the number, so it's just square root of 2, square root of 2. So that's how you do the difference of squares. That's what we've done since algebra 2 days, pre-calc, the beginning of the year, we reviewed factoring. So my 3 numbers are going to be -6. We're going to have -1.41, that's square root of 2, and positive 1.41, and no, I'm not drawing that to scale it by any
Did you know at the top of your head?
What?
That was 1.4.
What's square root of 3?
Or did you do it because you knew?
1.71.
So you just know off the top of your head.
Oh, I only have a select few memorized from calculus, from
What's
calculus when
seven?
I was in high school.
Oh.
So just
Wait,
rough,
high
just like
school?
one or two. Yeah.
Or I tell you, I'm not gonna do these numbers.
What's the square root of 7?
That one I wouldn't even know. It's above 2.4, 2.41.
You have 5. You should know 5.
Maybe 5 is 2.41. No, 5 would be 2.2. Anyway. Okay, here's what we have.
5 is 23.
I would have had 2.2.
Seven is 2.65.
0.65. Okay. It was in the ballpark.
Yeah, you were pretty close.
Are we allowed to like draw it 2.2
What?
as fast as you do?
Yeah. Yeah, it's rough scales. Yep. I don't want anything
No,
super
you
exact.
already found
Really,
like
the only thing I
one
need to
thing.
make sure of is I have the x-intercepts correct. The y-intercept, you can just fill in those numbers later. So like for mine, I know that the y-intercept in this problem is -12, because you plug in a bunch of zeros, you get -12. So I'm just gonna plug this in. And no, they're not drawn to scale. I'm just giving you the rough sense where it's going, okay? It's not symmetric because the x-intercepts were there, and it's bouncing every other power for even knobs. Turning points. A turning point is how many times it turns directions. This one potentially turns directions twice. You take the highest power and subtract 1 off of
I
it.
have a question.
Okay, hold on. I'll get to it here in a second. Now, the x-intercepts, there's potential to have 3. Same with like the turning points, it has potential to have 2. Why there's 3 x-intercepts, the highest power is 3. It doesn't have to though, because maybe this thing is shifted so far down that all the little squiggly stuff happens out here, so it might only have 1. So it really depends on like that back number, like how far it's been shifted up or down. Now I picked these out because I have very clean, easy numbers. Now that's just the normal functional value. So is there a question on that part?
No, you kind of answered it.
Okay, so now, the next part is doing first derivative graph. First derivative, we have to actually calculate that. So on that function over there, 3x squared, 12x minus 2. This, that's the first derivative, right? That's doing the simple power rule over that thing right there. That picture is what I'm going to draw next. So why I did this. If you don't want to use any other shortcuts that I showed you yesterday or the weeks leading up, to this last chapter test we had, you could just draw this picture the same way we just did that one. You find x-intercepts, you find end behavior, you do the multiplicity test if you're going to bounce off an x-intercept, you find y-intercepts, and you just draw this picture, and it will mimic the first derivative graph, which is fine. That's why I'm showing you that stuff, because it will give you the best way to draw it. Does that make sense?
Mm-hmm.
Okay, so if you want to do this, I know it has a y-intercept of -2. If I were to try to factor this thing apart, I can't make 12 in the middle, so
Are
to
we only
find,
gonna do the first derivative?
What?
Like, for the
Not
problem?
the second derivative.
you have to do second derivative and to find the
Wait,
factor.
why is it 390?
Wait, what?
I just missed that one.
You have to do first derivative drawing, like the original drawing, the first derivative drawing, and the second derivative drawing.
Wow, seriously?
Look at how much time I have, I don't feel like I
I was like,
So, alright, now, to find x-intercepts, on this particular case, if it's not factorable, you can always do quadratic formula, which I'll do on this one. You could do the rational root theorem, where you find potential rational roots. For me, I'm going to do the quadratic because it's simplified. It should be easy to find them. If you want to do the rational root theorem, this is how you do it. You take the back number, you put it over the front number, and you make you break these down to the factors. So like
Not negative?
negatives come later. We put the negatives on there later. So you break down the factors of 2. You break down the factors of 3. And you make every combination, and these are the potential x-intercept numbers that are rational. It can be 1 positive or negative. It can be 1 over 3 positive or negative. It could be 2 over 1 positive or negative, or 2 over 3 positive or negative. These are the potentials. Now, it doesn't have to be, because these are just rational. If it turns out to be weird decimals, that's where the quadratic formula will do the job for you. So if you want to do this, where you want to plug these in and see which one gives you 0, there's 8 numbers to plug in. You can choose a calculator, you can figure that out. I'm going to just do the quadratic formula, but this is a way that if you didn't know how to factor this method, works on that first prime as well. You break up 12, you put it over the 1, that's the front number. You make every combination of the factors, and you eventually find that -6 was one of them that worked. Okay, and then you can find the others using, factoring it apart. But on this case, I'm going to do the quadratic formula. But this is the way that you could do that prompt.
Opposite B.
Okay, so -12.
Minus 4AC all over 2.
Should we always just do the quadratic formula?
I do on the second derivative because usually you're already down to a quadratic. You can't do it on that one because it's power of 3. You can only
But
do
you can factor out
quadratics.
it, it just.
Yeah.
Plus or minus
On
the
this
square
one, you can
root.
factor out an
It's
x
all
first and
over
then do it.
B squared
Okay.
minus the 4 times the
Okay,
ax.
what this is giving me that first derivative. It's giving me my x-intercepts for this derivative. And so what we do is this will be a 144 minus this, or actually it's going to be plus. This is 12 times 2, that's 24. There's a 6 on the bottom. There's a -12 plus or minus. So this should just be a 168, which is almost 13. It's like 12.9 if I take the square root of like 160.
12.96.
12.96. Okay.
How did you know that?
Because 13 is 169. So it had to be like all the way up to 13. It was like 12 point something, and it was just right to 13. So this is about 12.96. We're going to add it to negative, so that's 0.96, and you divide it, so that's a really small positive number, so it's like right in this range. Okay?
0.96 divided by 6, what is that?
Then the next one is you take -12 minus about 13-ish, so that's -25, and you're going to divide by 6, it's about 5 point something, and it would be negative. So -5 point something. And this is point, really small number. So, again, if you want to type it in your calculator, you can figure out these are exactly. I'm just figuring out that square root 12.96. You're adding it to -12 divided by 6. Type it in your calculator to figure out the exact numbers. Okay, now, how I figure out where this graph is going. I know that the tails have to face the same direction, and they're going up. Because what tells me that?
Cause the
Positive.
Exponent.
How do I say it?
The highest degree. It's 2. Tails have to go up. If it's 4, tails go up. If it's negative out front, tails go down. So they're going up. So this is probably what's happening.
211.
It's probably doing that.
We did
Because-
catch the -2.
Or that's actually.
Oh yeah.
Yeah, you didn't have to do that.
Good point on that.
I mean, correct me.
I didn't even
Oh, yeah.
I didn't even think of that.
Oh, this is not.
Alright.
Oh, you mutilated
You
that
didn't
thing.
help it anymore by putting a line straight.
Alright.
Okay. It's like a 90-degree angle.
Alright, so there's your first derivative graph.
It's supposed to be symmetrical.
It's good.
No, definitely not.
What I
The reason why they're not balanced over the y-axis. One's really close to the y-axis, one's really far. So, not so much.
Done it all.
Okay.
That's
It's probably a lot better than what I've drawn. We'll go with it. Alright. Second derivative test. Second derivative.
Just me being smart over here,
Alright, second derivative.
All
Alright.
right.
Let's get rid of this. Alright.
What's he saying about it?
Okay, second derivative on that
Second
one.
derivative is gonna be something.
Yep. As you go, it gets smaller and smaller. So, second derivative test. What do we got? 6x plus 12? Alright, so 6x plus 12. That's my second derivative. Drawing this is a linear function. It's a line, there's no powers on it, so it's a line. I can actually figure out where it's actually going to hit if I just set this equal to 0. I don't need to do quadratic formula or anything like that for x-intercepts. So I can just set it equal to 0 and solve it really quick. So it'll be negative.
-2, sure.
Yeah. So this will be -2. That's where it's going to hit the x-axis. And so -2. And the slope, because it is linear, it's going up 6 over 1. So it's linear.
Is it?
There you go. -1, this is 6. Alright, there you go. There's your line.
Why is that 2 so ridiculously?
It was the first one I did.
That's the first.
Well, you gotta put the line for the y.
Why did you not want the line? What? You are not having a good day graphic, are you?
Okay.
Did we look at mine?
Alright.
Is that as far as we need to go?
Never done? And then on to the next one.
You get the
On to the next one. Now, hey, we're we're figuring out the first derivative graph, second derivative, just using common sense stuff that we've learned.
Crikey.
We're going through them all the way now. The one thing we haven't really talked about today was that what first derivative test actually does is it finds these points of where it's actually going from like it's going towards zero slope. That's what these numbers are. These are the points where you actually hit zero slope. That's what these numbers that you're finding here for these x-axis numbers. On the second derivative, that -2, that's on the original graph. -2, it's like right about here-ish. That's the point when it turns from concave down to concave up. That's what we're doing. You don't need to like state that, but it's something like in the back of your mind, you do need to know that. That's why we're finding, you know, these x values. That's why we find the x value over there, because those numbers are important. Yeah, so it went from, you know, concave down, and at this like moment, -2, this is when it starts to flip to concave up, because it starts to rotate. Those points, like where it's going from like concave down to concave up, that's actually called an inflection point. Not a turning point, an inflection point.
Yeah, yes.
So, second derivative on this. Just this derivative.
I missed that whole thing, that's trying to figure out.
That's when it rotates.
That was it.
So the top rotation.
Or where is that? What?
Bro, that's how I know it is.
This highest point, this highest point is this x number right here.
That's what you were talking about.
No, inflection point for changing from concave up to down, that number is the -2 number that we found on the x-axis on the second derivative. That's an inflection point when it changes from concave up to down. What we found in the first derivative is the peaks and valleys relative to maximums. Some people have that idea like a turning point and inflection being the same thing, they're not.
That's why like everything in our body is
What?
ridiculously
I was
changing.
wondering.
Why can we focus the lower arm?
That was just going up 6 over 1.
40 letter.
Then I knew that, you know, from here to up 6 over 1 spot. Because the slope, it's
Yes,
just a
the
linear,
whole
it's a linear route. It's 6 over 1 for slope.
Like this
Oh.
turtle,
Black holes
can we
MX
just
plus
call it like a small necklace? You know what I mean?
On the 6 over 1.
Yeah. Because it's just linear, y equals mx plus b, the 6 is your slope.
So we had to call
Six.
certain breeds.
Because it didn't have any curves, so that's why.
Yeah.
Not hard at all.
It's literally, it was designed that way. Like
Alright, what do we do now? Okay, are we good? Yeah.
I want to read something here. Yeah, please don't
Yeah, we only got one more problem to do. One more.
That's why that whole world is.
Can you put it on the board? You should put it on the board now.
I can't.
Use
Hey, can I get rid of this stuff though?
Use your abundance of marker board space.
Okay, I'm good now.
Alright, we're good? Are you good? Okay.
We still wouldn't be able to do the things that they did.
Mr. Ward, how many tries did it take you to make that cylinder over there? That one.
Once.
How many tries did it make you to make that prism?
Say you know what.
How many tries did
We
it take you to
wouldn't be
make
able
the
to go
prism?
back in time.
The prism?
Yeah, that's how
Once.
you make the
What
light.
about the pyramid?
It's like,
Once.
just see
Did
how
it only take you
crazy
once for
it is.
all of
So,
them?
like,
You're
everything,
really wrong.
like, we still have
Is
to
it
do
the
the
12
research.
supposed to be a Y
You can't
or
test the
something?
reason.
This is
That energy
What?
field. Like,
Y
that
goes
was like a
MX plus
mile
B,
or
is
two
it
long.
B or Y?
I don't know if I believe
Yeah.
That last one, yeah. So it would
This- this-
Oh, you had it
I-
on.
I-
It doesn't
I-
fit
I
six
still
on
don't know.
one.
No, he
that
had
was,
it-
that was over
That
one
was
spot.
up 6 over 1, so it was -1/6.
I kind of labeled that one wrong.
Is as far as they can.
Alright, here we go. Last problem today. Again, these are kind of the limit of what we're gonna have to do. Okay, so let's kind of think about this particular problem. It is factorable. We don't have to do any rational roots. We can pull out an x out of this first part, x squared, sorry, out of the first two. So that's gonna be x squared, that'll be x minus 3. Out of the back, what do I
Negative
factor?
1
A 1.
or 1.
Just a 1.
I would have done negative.
Now,
Why?
because you gotta make the parentheses look the same. If you would have put a negative, they would have been opposites.
Yeah, but you could pull out negative x.
Alright, so what we have here, this is gonna be x squared plus 1. And this is x minus 3 if I factor. This problem only has one x intercept. Now, the reason why, it looks like the other one, yeah.
Do you want a square root or plus for me?
Okay,
Oh, yeah.
okay, so,
Consider this the
hey.
complement.
no talk, let's go. So, Real quick, we're only hitting one x-intercept
You
number.
can't take the square root of a negative.
That's 3. Yeah, and the idea here is that this part right here doesn't have any x-intercepts. You can't square a number, add it to 1 and make 0. Because the smallest this will be is 1. Because if you plug any negatives and you square it, it'll make positive and you add it to 1.
What if you plug in 0 and square
If you plug 0 squared and you add to 1, you'll get 1. You'll never actually hit the x-axis at this point. So it really only has one x-intercept. But just knowing the concept here is that since this is a power 3 problem, we know that the tail's going up,
Can we
the
just do the
tail's
square root
going
of
down. We know that the y-intercept is at -3.
We can have imaginary numbers.
Yeah, and that's what this one has. It has imaginary x-intercept numbers.
Oh, not
But
this crap again.
what it's actually doing is it's doing this.
Ooh.
So that's the imaginary one right there?
Yeah, like these two right here are the imaginaries, where if this thing was shifted higher, it would have hit the x-axis twice. But it didn't, right? That's why it's imaginary. That's why it's x squared plus 1. Didn't actually have a root because this thing was shifted down too many. So it's a little bit different than the last one. I want to kind of show you that. Now, this problem still has a first derivative. It still has a second derivative. It still has a peak and valley. No, relative max and min. That's what the first derivative tells you. It still has inflection points when it goes from concave down to concave up. So the inflection point would be like somewhere in this range when it actually switches from down to up in that motion. Okay, so let's walk through this problem.
I thought we were just did.
Well, we did the first drawing. Not symmetrical or something like that. We got everything pretty much labeled what I need. Let's go to first derivative test. So first derivative.
3x squared minus 6x plus 1.
For my safety.
No, he likes.
I agree with
I
that.
know, but he's still making.
Hey, seriously, stop.
Yeah.
It was Justin.
Now, this part can, it's not gonna be factorable because we can't break up 3 into 1 to make the 6 in the middle. So what we're gonna have to do is quadratic formula again.
Opposite B plus or minus square root,
So,
b squared minus 4ac all over 2a.
Minus 6 squared, I'm just gonna say 6 squared because we squared.
Wait, why did you-
Can we just write 36? I mean,
4, yeah, I know.
Why'd you put
3
positive
He said
6 on
He
the
said it
outside?
out loud. He said positive.
Because I said opposite B.
2 times A. Alright, so this is gonna be 6 plus or minus
That's what I thought.
36 minus 12 all over 6. That's going to be 24. The square root of 24 is not a nice number. It's almost 5. It's 4.9.
What is it? Lucas, check it.
So it's 4.9697. something like that.
You want
Four-
me to check it
four
out?
point nine
No,
six seven.
look at that, 6.
Darn it.
4.9.
Alright, so we have a 6 plus or minus.
It's 4.89.
8, not really?
Yeah.
4.89.
8?
Sure.
4.8989794.
I don't know how to say this in my field.
Okay, anyway, so these are my x-axis numbers. So 5.8, we're gonna add that to 6, we get 11. You divide that by 6, you get like a 1 point something. So, 1 point something.
Yeah, high one.
Yeah.
Now,
Now,
actually, it's 0.9. The answer is 24.01. I said if you said that it's 4.9, it's not. If you square 4, it's not.
If you square
4.9 squared
it's
is
24.
24.01.
you're way behind me already. I'm already past what you guys are.
E squared at least 12 more numbers.
Next, you're subtracting, this will be about 1, and we're gonna divide by 6.
0.19.
So, 0.19. Alright, so these are my x-axis numbers are. It's got a positive power of 2, so the tails go up. And it's got a y-intercept of 1. So it's doing something like this. There's your first derivative graph. Okay? Moving on again, these decimals,
Shouldn't your
That's
y-intercept
two
be a
districts.
negative 1?
1.
No. Positive.
Positive 1.
Yeah.
Okay. Alright, second derivative test.
You ever dab?
I am with that.
So it's gonna be 6x minus 6. That'll be bigger than this. So you hear that word? 6x minus 6. Certainly.
Alright, what are we on? Second derivative test. Okay, second derivative test. What do we got? 6x minus 6. Alright. This is linear again. It's linear. It's definitely hitting the x-axis at 1.
1.
It's 1 for the x-axis number. It's going to be rising 6, running 1. So this spot here is 2 comma 6. It's hitting negative 6 down the road.
Bingo.
There you go.
Easy money.
Here's your spots.
I like that.
Okay.
Okay. Are we done?
All right.
Assignment
Now,
done.
remember, I'm going to give you your assignment here in a minute. It's 5 problems. Okay, just remember. Graph, what first derivative test actually gives you, like these two numbers you're finding right here, that's your relative max and min. The second derivative, the number 1, the x-axis number, what you're finding there, the number 1, that is where this thing did an inflection, where it changed from concave up to concave down, that type of thing. So this graph is actually shifted over more. My picture is not accurate. This thing should have been over more like this way, where the actual inflection from like down to up took place at 1. How I know that is because that graph told me that. The second derivative, the x-axis numbers are the inflections when it changes from concave down to up.
What's the third derivative?
Usually in these problems it all fails. Like
There's no way.
what that would actually do would be the inflection points, like when it changes from concave up on the first. Okay, here's your homework. Okay, 5 problems. What exactly homework paper? This is going to be due on Friday. Number 4, 14, 15, 26, 31. There's your 5 rounds.
Thank you.
Do when?
Friday. Do Friday. Should be straightforward. You shouldn't have to take too
I'm not
long.
gonna be here Friday.
Do when you get back.
Okay.
Now, tentatively, we had scheduled that we're going to start reviewing Friday. We'll kind of see. We still have another section to go into. That's the next section we're going. We don't know if we'll get done with that section by Friday. So we'll kind of play by ear. Test is tentatively next Tuesday.
I feel like Tuesday is.
And if you haven't turned in today's homework, page 146.
That would make sense. Would it be worse if you had a test? I'll be very nervous and I won't be able to do it. Yeah. Oh, actually, like people are like, oh,
No, dual threat. He's definitely dual threat. He runs a fair
what chapter
amount.
is it? I don't know what double page is in the book.
He's never in the pod. He probably has the strongest arm in the
I
NFL, but
actually
he's
am not
definitely
going
dual
to. I
threat.
don't know.
Definitely not a pocket
Pocket passers don't scramble. Tom Brady's a pocket
I
passer.
actually have like
And he hit 1,000 rushing yards.
Mahomes throws out of the pocket the majority of the time. He's good at improvise. So I kind of like Carson Wentz, I believe, a lot stronger on it.
And a lot more athletic.
A lot more like Brett Favre confused myself.
He's kind of like Aaron Rodgers.
Yeah, me too.
He's never supposed to be like Brett Favre.
I don't know. Rodgers is one of the most
Rodgers makes
Yeah, you know, before I take shows my face before I got the job.
It goes like 7 minutes.
He probably has a
I think Drew Brees
I know, I'm not saying you're like.
Drew Brees has it.
Yeah.
Justin, do you think Mahomes could eventually
I'm gonna go through and see what
Mahomes could eventually be?
what parts I know and things I don't know.
Do you think Mahomes could eventually be compared to Brett
Just
Favre?
checking to see.
No,
if
because he's one season in. He's one season in. Colin Kaepernick was also the same guy. So was Dak Prescott. Still.
Dak can throw down field goals. He throws like 5. He's got
Things like I already said.
Brady Rodgers might be more talented.
How do we find that's the only thing I know.
I think that Aaron Rodgers is more talented if he would throw for more yards.
Threw for 7,000 a
Yeah, you have
year.
to rock our
When Aaron Rodgers came back and said, no, Tom Brady's the greatest of all time. He's won 5
we
Super
have
Bowls.
a
Yeah, and it was before they played each other.
Yeah.
And then
Chris comments are wearing the same outfit.
Were they?
Yeah, they both have
You're
like
not
hats
gonna
on.
need to know that word every time, but you're
Some analyst was going on. The fact that anyone would ever compare me to Roger.
Yeah, I
Just
saw
know
that.
that.
Ridiculous.
You don't need to know words.
You were disrespecting the race quarterback of all time. He has 5.
And the other ones are.
I love Tom. The fact that he is the oldest quarterback in the league and is in the 4th
And you
ranked
can have
in
those
power
with
rankings,
the
the 4th ranked.
Well, he's the oldest quarterback to ever have a statistically good season already, and he's having another one.
And also the fact that
Garbage.
the
The
fact
fact
that
that Hickman, he hit 30, so you went from Hickman from breaking the touchdown season record to irrelevant and being able to correct him.
I know why I didn't do my
yeah, well, he threw like the most interceptions.
Yeah, and then they won the Super Bowl because of the.
I don't know how many times I have to say it to
On
you.
Miller,
But I'm
single-handedly
not
won.
gonna- Yes, I am gonna.
He led his
Yeah, he like
synthetically
3
ever.
sacks.
The offensive player did not.
They have so he did like about it. He's like, why
Well,
not
that's
send
the worst part about.
it costs more than you're gonna get.
You trade like the Bears gave up all that for Khalil Mack. Great player.
I would probably said it because you
A
implied it.
defensive player can win a
And you're
game,
talking.
but a defensive player
Yeah, so you're
doesn't
just
win a
saying that you
Super
do less
like
than
a
possibly I
season.
do.
Like a quarterback can lead you to the Super Bowl. Khalil Mack will not lead the Bears to the Super Bowl.
Okay, but the
I'm
Bears
fine.
kind